Hello, welcome to another PlayBASIC tutorial. Today we're going to be looking at making the transition from variables to arrays. And hopefully at the end of the tutorial we'll get something like this little example here up and running for you. So we've got some moving characters that represented as circles, all doing different things on the screen. But let's go back and start at the beginning. Let's go back to variables first of all. Let's get rid of that. Open a new project. And we'll start at variables. So previously we talked about variables, and these are what represent individual pieces of data in our programs. We have two different types of variables generally. We have numeric variables and strings. For the purpose of this tutorial, we'll just look at integer variables and integer arrays. And those are these kind of numbers that are numbers like 1, 2, 3. So there's no fractional part of these numbers. 55, 62, 2046, they're all integer numbers. Okay, so in PlayBASIC, how do we create a variable? We can use implicit creation, which just means that as it's scanning through the code, anytime it sees a word it doesn't understand, it just assumes that's a variable, or it might assume it's an array if it has brackets after it. In a game, we might want to use something like, we want to have a variable to represent the score. We can use, so we would type in score. We might want to assign that some value, so we have an equal sign after that, and sign it 1000. So if people comes down from the top down, sees this new word, goes, okay, it's not declared anywhere else, and it's not a command that I actually understand or have predefined behavior with, and goes, this must be a variable. Keeps looking forward, goes, okay, there's an assignment there. We have to, or the programmer wants me to assign a value to this variable, and we look at the end of the expression, we see 1000. So when we run the program, it's going to copy this value here into this variable. Before we can do that, we'll put sync and the wait key at the bottom. Otherwise, when we run the program, it'll just flash on and flash off. Now, how do we know that even worked? Well, we don't really. So we'll have to display the score variable out to the screen using the print command. Try it again. We can see that score equals 1000. Now, because score is a variable, we can alter its current value, up, down. So we can do things like addition, subtraction, multiplication, division, of course, and a few other operators in there as well. So you could go, score equals score plus 50. If we print score out again, we'll see its value is now 50 larger than what it was when we saw it the first time. Not in this kind of very initial state, it's not very useful, is it? Let's take our example to something a little bit more like what we would use to represent a character in our game. Now, games will have lots of different components, but generally any kind of player character on screen, like a Mario game, for example, the character is going to have its x coordinate. So we might have a variable called x, I often just call it x pos. Let's say in our game it's going to be at position 400, say, a y coordinate at, So the x variable represents where the character is going to be on this horizontal axis across the screen. So if we run it again, this will be the position from this left-hand margin across the screen to here. By default, the screen is 800 pixels wide. So here is position 0, hard against this margin, and 800 is over here. It's actually off the screen, 800, but Y is the same. 0 is at the top. You might be expecting it's at the bottom, but it's actually at the top, and counts down. So 0 on the y-axis is up here, counts down to 600. So there's two variables here represent our conceptual character. So let's render our character using a circle, because we don't have to load any media or do anything too stressful. And our circle will be at a radius of 32, and it will be filled. That's all the truth on the end there represents. If you want information about a command, put the cursor on top of it and press F1. Hopefully that's capturing for us. Just bring that in there. So it gives us information about what the parameters are, and hopefully a bit more information about things. And often there's what we call mini tutorials on the exam. They're pretty much just very bare bones examples to get you up to speed. Getting back to here, let's run our example anyway. So we have two variables that represent our character's position on screen, and we have drawn our circle at those variables' position. So if we sort of track down what PB is doing, starts at the top of the program, comes down, sees this word here, goes, I don't understand this word, so I will assume this is an integer variable. So this is what we call implicit declaration. Anytime it sees a word it doesn't understand, it just goes, well, that must be an integer. Moves forward, sees the equal, says, okay, you want to assign this value to this variable at this time. It keeps moving forward to the next line, so there's another variable there, y position, which we're using to represent where our character is down the screen. Moves forward again, sees the circle command, and we're using our variables for its position on the x-axis, our y pos for the circle position on the y-axis, and we've got our radius and our true flag to tell it to fill the circle. Okay, that's a very simple program, but we haven't got any sort of movement. We haven't got anything interesting about our little program, so let's put this all in a loop. It won't move at the moment, because we've just got a declaration. We're rendering the circle once, rendering the screen to the user, and then telling it to wait, and then just PB continues on down until it hits the end of here and just stops and returns back to the editor. So when I'm running this thing, when it's sitting here in front of us, PB is just sitting there waiting for something, waiting for us to press a key. It's not doing anything. What we need to do is place this inside a loop. We use the do loop structure. You could use any one of these loop structures, but we'll use a do loop. If I run this now, something different is happening, but visually it's exactly the same. I'll hit F5 to run it. Our circle's on the screen, it's not moving, it's not doing anything. But the program's actually running through this bit of code here constantly. And it's not moving because we're not altering the variables here, our X and Y position. Let's do that. If I modify the value in X position, if I go X position equals old X position plus 1, when it comes down here the first time, it's going to draw the circle at X position's current value, which is going to be 400 initially. Draws the circle, moves on, moves to the next line. So we're adding 1 to that X position there, which means that circle is going to be at 401. We're doing a sync, looping back up here to do. We do this whole thing again and again. So every time it loops through, the X position is moving up 1 position, and our circle will be drawn one coordinate across. So let's watch it. A couple of things there are problematic, but our circle is created this stretching looking thing over here because we're drawing the initial circle here, we've drawn it again, one across from itself, but we haven't actually cleared the screen of where it used to be. So place a CLS at the start, use the RGB command to pick a colour, I don't know, kind of a dark blue I guess, just a random colour off the top of the head. So this will clear the screen, draw our circle, move our coordinate, come back, clear the screen. So the viewer, we're seeing this thing animating off the screen. I might slow that down a bit actually to make sure it captures better. Set the FPS rate to 15. I'll set it to 20. Hopefully you can capture that. Alright, it's pretty slow, but you get the idea. But our character is actually moving across. Now, if we want to move it on the y-axis, we would alter the y variable. What if we did y equals y position -2? So it'll move up the screen faster than it's moving horizontally. So it'll kind of move diagonally. Cool. Getting somewhere, aren't we? Using our variables to control a single character. What if we wanted to have more than one circle though? What if we wanted to have two circles? We could do this. We could have x position. I can make another pair of variables here. I'll call this xpos 2. I'll put this one here at 100, 100, let's say. And I'll just put a comment in there, draw circle 1. And I might change our variables too. Let's call our initial variables xpos 1. So this is kind of the, in our programmer mind, we're kind of going, okay, this is the x position of character 1. That's the y position of character 1. This variable here. So we have to change the variables down here too to match up, otherwise it won't understand. If we run it again now, we should get the same thing. Nothing is functionally different. That's okay. To draw the second character though, bit of cut and paste magic. Since we're drawing character 2, which is xpos, which is our variable pair xpos 2 and ypos 2. We'll make the circle a bit larger so I can tell which one's which. And I'll just get rid of those comments there. So we're running it, and we have two characters on screen, or two conceptual characters on screen. It's a bit tedious though, isn't it? If we use variables for every character and we have hundreds of different characters, we end up with lots of variables. Now, let's move our character 2 there, just because we can, you know. We'll make him move, or make it move 2 and 2. See what happens. It should move down and across. Cool. When they get off the screen, they will just disappear. So we haven't got any logic there to tell them what to do. We could do something like here, for example. We could check if y position 1 lower than 0, then we could do y position 1 equals ypos 1 plus. Now I know the screen is 600 high, so we can just add 600 to it. And this should move it from up the top down the bottom. Let's see if it works. Wow, look at that. So every time it crosses over that threshold, this top threshold here should be reset down the bottom. But that will only affect its vertical position, the Y position. We could use something like a bit more adventurous, actually. We could use the wrap function for this. You could go y plus 1 equals wrap value, y pos, and we'll say 0 to 600. And this will actually handle, this will handle when, both cases, when y is off the top of the screen or off the bottom of the screen. Or if we have one there for our x coordinates, we'll adjust those for the screen width, which is 800. It should work on those as well. I might move the character a bit faster so we can sort of get through this a bit. Let's move this guy at moving at 2, so this is at 1, 4. So he'll move a bit faster. Okay, so he's wrapping vertically pretty good. This character here is not wrapping because it has no logic to support him, or her, if you want to think of her so. So we're keeping that character within inside the bounds of the screen, but moving in that direction forever. And just keep moving and moving and moving until I hit break. So this is controlling this first circle, and this is keeping the circle inside the screens. We've got these secondary variables here. So you can copy this down here and sort of go, well, okay, now I can have the same kind of logic for character 2. We'll give it a go. Now for a short program like this, it's not the end of the world that we're only using variables. But what we could do is we could use what's called an array. That would make storing not just handling two sort of conceptual objects on screen. We could store and handle lots of them. So let's have a look at that. What I might do is I might just leave this example the way it is there. I'll just put an end statement at the top here, for example, and put a comment above that. So we'll code below, put a new code above that. I just don't want a new program up here to run this old code down here. Okay, so variables store individual pieces of information, and we can modify that variable. We can use it to represent a position on screen, or we can use it to represent any kind of state within our game. Maybe the things that you use variables for. You might have a variable that represents what the current level you're playing is, the name of the player, or something like that, or lots and lots of things will be variables. When we need to control more than one piece of data, but we want to use through one container, this is where we start looking at arrays. Now, an array is like a filing cabinet, and unlike variables where you can just type the name, variable, and PB sees that and goes, okay, this must be a variable, because it doesn't know what it is. To make an array, we have to use what's called the dim statement, and so we type dim space, and then we have the array name. In this case, I'm going to use xpos, which is going to represent the x positions of our, let's say, 20 characters. So what you would do is you put a bracket, and you have 20 end bracket. So when PB sees this, it comes down and goes, okay, I see a dimension statement. You want me to make an array, and the array name is going to be x position. So anytime I want to deal with this array, I use xpos, and then I give it the brackets and the what value, what position within that data, or what the location within that data is probably a better way of putting it, from that set that I want to either read or write to, and it needs the size. Now this is what we call a one-dimensional array. I might make it a bit smaller, just so I can fit the results on here. But arrays go really perfectly with things like for next loops. I can use a for next loop now to iterate through and reveal all of the contents of this XPOS array. I could go to, say, for loop equals 0 to, and we know there are 10 items within this array, and we'll just print them all out. Print XPOS. We'll use our loop variable. So initially we're printing out. Oops. I better put a sync and a wait here at the bottom so it doesn't just run off. Let's run it and see what we get. We get something that's not very interesting, isn't it? We're getting 0, 0, 0, 0. Now why is that? Well, when the array is created, all of the cells inside it are initialized to 0. If you wanted to set any one of the available cells to a value, because this is an integer array, so we can store integer values in it. Let's say we wanted to store something at position 5 in the array. We would go XPOS bracket 5, end of bracket, closing bracket, I guess is a better way of putting it. Let's store the value 888 in there, and we'll run the program again. As you can see, at this position here, we've got our data, 888 has been stored now. We might just make this a bit fancier actually. We'll use a bit of string magic there. I'll just also have the loop counter, which is the position within the array and the contents of the array. Okay, so on the left we've got the loop, or the array index. So at 0 in our array we have the contents of 0. At index 1 we have nothing there, so we never put anything there. 2 is empty as well, 3 is empty, 4 is empty, and at position 5, as you can see down here, we put 888 and nothing in the rest of them. Yeah, we could do something. If we put something at position, I don't know, 9, we could go equals, you know, some big number, and we can see this represented here. Now, you can use what's called the debugger to view arrays too. This is something that's not that well known. I'll just give you a quick look. If I run the program and I hit F7, it shows this weird looking debugger thing over here. Just pull that inside the view so you can see it. Hit stop, I go to variables, and it shows me the variables in the program. It shows me some variables in the program that we're not actually using, but this XPOS here, that's our array. If I click it, it shows the title of the array, the size of the array, it shows the type, a bit of information about its bank or handle as it's known, and then the contents. As you can see on here on the screen, well, it's kind of squashed up now, we're looking at that. So that's one handy little thing you can use to check what's in an array as your program is running. Now, all this is all very, well, it's not very interesting, is it? We're looking at sort of a, code to control game characters, and now looking at this kind of boring initialize stuff. Before we had, in our previous example, we had two sets of variables, each pair of variables represented. This was representing character 1 on screen. These two variables here were representing character 2. What we could do is we could have an XPOS array, and we could make a YPOS array of 10 as well. So we've got space for 10 different Y positions, and we've got space for 10 different X positions. Because these arrays are like filing cabinets. You know, just think of them like that. You've got this kind of empty cells. So each cell has an index, and the index is unique. And they just step up. They start at 0 and they go to whatever this highest value here is. So this one here, this XPOS array stores 10 different values. This one stores 10 different values as well. Oh wow, we are rushing today. I'm super cold, and I actually made this tutorial about 3 times and had problems with it every time. But pressing on. Let's try and represent our game. Let's make a version of this code here that's using arrays to see a simplification. So up here, I'll just cut that here. Now, XPOS there is a variable. Let's put a, now we're talking about XPOS array and YPOS array, and here we need down here. Right, so we've got XPOS array and YPOS array, and at the index 1 in these two arrays we're storing, this is the position of, oh wow, of character 1, massive typo, position of character 1, oh the keyboard, sorry, I've got weird keyboard mapping on this system, I always forget that. Down here we've got this is going to be our position of character 2. So we've initialized its position. We'll make our do loop again, do loop, place our sync statement there, and we'll place our CLS at the top. We'll have RGB, we'll make it a bit of a green colour or something, I don't know, just because we can. Right. This time we will draw the two characters we use a for next loop. So if I go for loop equals 1 to 2, there are two characters, aren't there? So we want to loop from position 1 to position 2, that's the second character. I don't need two loops, I can just use the same index to look at the two different arrays. So we can do this, we can go circle, XPOS, loop. So whatever loop is going to index it, oh, sorry, YPOS 32 and true. Now, let's run that, see if it runs for starters. We get something that's kind of similar to what we had before, but not exactly the same, is it? Before, these two characters here could be separate sizes. Now they're not. Every time we loop through here, we're drawing both characters size of 32. What we could do is we could have an array up here that holds the size of each character. We need 10 slots. So down here we could go, size of character 1 is going to be 32. Size of character 2 is going to be, was it 64? Down here we go size loop. So when it draws the circle, it gets its x coordinate from the x array, gets the y coordinate for the y array, and the size from here. So when loop is 1, is getting this value, or when loop is 1, we're getting this y value in there, so we're drawing the circle at 400 on the x-axis, 300 on the y-axis at 32. When the loop steps up, steps through again, and loop is then equal to 2, this is drawing, we're using this set of values here, so the circle will be larger. That looks a bit more like it, doesn't it? They weren't moving before, so, but again, see how they both have different movement behaviours? Character 1 has moving, I think it was moving up and across, wasn't it? That's when he was moving down and across. We could have another pair of arrays that deal with x speed. So this is the speed of this character along the x-axis. Another one for the speed along the y-axis. Everything's nicely paired up, so we go x speed of character 1 is going to be 4, I think it was. Y speed of character 1 is going to equal -2. So what we could do is we could not only draw the character's line, the character inside this loop, we can also manipulate its position by doing this. X plus loop equals x speed loop. Oh, sorry, it should be plus, shouldn't it? So look, when loop is 1, we are looking at this x position here, this character of all of these array offsets, all the separate arrays. So we're using multiple arrays to store a bunch of different information about our conceptual characters. So to move the y-axis as well, we have something like this: y pause loop plus y speed loop. Let's try and run that, see what we get. I think I'm at a typo, yeah. How unusual. I'll just put a speed limit at the top of this to make sure it's going to capture all right. Was it 20 frames per second? Back to the middle here. Running it. Okay, we've got a bug because our y coordinate is not correct. We made some sort of mess up in here. Ah, there it is. Yeah. Character 1 is moving, character 2 is not moving. It's not that it's not performing its logic, we just never bothered to initialize x speed for character 2. I forgot what they were before. So character 2 is moving 2 along the x-axis and then 2 along the y. So character x speed is going to be there. Yeah. Yeah. I hope you're following this. I'm sorry, I really apologise. It's pretty bad. But, you know, hopefully it gives you an idea of how you can use arrays to control groups of characters. Let's run it and see how we go. And we do actually have 2 different characters on screen running. But we had that before, didn't we? What if we do something like this? Let's make a variable called number of... Oh. Let's continue on. Before we're interrupted, we were talking about, look at our characters set up using a loop to process our characters. We're only doing 2 characters out of a potential 10. To make it easier, what we'll do is we'll add a variable that represents the number of characters. We'll We'll call a variable exactly that, number of characters. Set this value to 20, let's say. So this is going to be the number of characters out in our little mock-up game world. So each character is going to have an X position, a Y position, a size, a speed on the X-axis. So all of the arrays will need to be the same size. And if we go to the bottom here, if we change our loop to loop from character 1 to the number of characters, it will actually draw all 20. Let's run it and have a look. Probably thinking, wow, did he make a mistake? Well, not really. We've got 2 characters, but we haven't defined character 3 or 4 or 5 or whatever all the way through. And rather than do this kind of tedious initializing of all of the parameters, let's use a loop. One of the great benefits of using arrays. We'll start from character 3, let's say. We'll loop through to the number of characters. Use our variable there. Back here. And we'll randomize them. I'll just grab a copy of all the properties. All of our array assignments, I should say. Oh, making a mess of that, aren't we? Alright, so use our loop counter variable here. So each time we're looping through, we're assigning the X coordinate, the Y coordinates of each one, these literal values, but that's very dull. If we run this now, we get not so much, do we? Number of characters, okay. Number of characters there. So what we need to do, of course, because we don't notice them, if I change the speed on each one, we didn't notice them before because they were actually all at the same coordinate. So since they're all the same colour, it's very hard to notice any change. Let's use the random function. Now I know the screen is 800 pixels wide, so starting position will start at 800 pixels at some random value between 0 and 800. Y is 0 to 600, so we'll give it a Y coordinates at random within that size. For size, we'll use random range. It can be, I don't know, between 16 and say 50 pixels for its radius. And its speed, this time we'll use random range, we'll go from say -5 to 5 on the x-axis, and for its y speed, hit the caps lock there again, infamous caps lock. Okay, now we should get something that we can actually see all the different characters. If I hit F5 to run it, get a whole bunch of circles just making their way off screen. It's possible to get circles that won't move, and that's because it's possible for the X position here to get a random number of 0, and the Y could get 0 as well. So something to sort of think about. Let's actually get rid of our stock standard character 1 and character 2, and we'll just initialize them all randomly. What else could we add? We could add a colour to each one. So each character could have an array. just say color. We'll use color loop, so we'll initialize it to a random color. There's a function in PV to make random colors, which is called random RGB. F1 to have a look at that. It's the equivalent of just doing this kind of statement here, by the way. And we'll use there's a version of the circle command called circle C, which is a version that will let you use a color. Let's run it again, F5, and now we get something like we had at the start of the tutorial. One difference though, isn't there? The characters are moving off the screen, but then they're not coming back. We could use our wrap value on the X or Y axis. So you could go X position loop equals a wrap value, X position loop, and the range we want it to wrap within, which is 0 to 800, and that will keep the X within the range, so the character can never move off the screen on this sort of horizontal axis. I just cut and paste and make the Y version of the expression. So the Y, we're clipping it to between 0 and 600. Let's run it again and see how we go. It's a bit like, I guess, sort of asteroids for those people who familiar with asteroids. It looks a bit silly though when the characters kind of just appear on the other side. It would look better if they smoothly went off the edges. So one easy way to do that is to change this wrapping size here. We could change this to say, let's say negative, well, sort of add a padding around the screen, so it won't wrap around until it leaves on the x-axis here, let's say, until it's left the screen by probably 32 pixels is okay, and I'll add that to the other side as well. And same thing for the y-axis, negative 32. I'm using just additions there so I can sort of see that's my padding value. Let's run it again. It looks a bit smoother, doesn't it? Of course, the size of the circle would actually dictate the kind of padding we want to have. Bigger circles will need a larger padding. So we could use the size here. Which is actually the radius of each character. So we could sort of grab a variable here and go, radius of our character. We could just negate the radius. Yeah, I might be losing a few people here. Bit of programming gobbledygook. And we'll run that and see how we go. So if you follow a character, just anyone with your eyes, you should sort of move off a little smoother than what it was before. That's a better solution, I think. And we have got a variable number of characters. So if I change this to, let's say we've got 5 characters running the program. We'll have 5. If I change it to 50, we get 50 of them. Now I hope I wasn't rushing too much there. I know I've kind of glossed over a bit of this stuff, but this is the concept we're trying to get to. We're trying to get you to a point where you can model your own characters inside your game. Put radius there if you really wanted to. You could actually condense some of these lines here too. We're trying to get you to a point where you can get your game logic running, and then worry about how you're going to represent the game or game characters later. So I'm using circles here. It's very convenient to do that, but you would use a graphic you've loaded from somewhere else. Obviously people who are familiar with what's called types would be going, geez, why don't you use types? Well, at this point we want to step from variables up to the idea of using step from the idea of using variables, which are singular pieces of data, to arrays that allow us to use multiple pieces of data, and then we'll step up to something called types later on. We might just pick back through the basic logic of the program again, just to make sure it's really drummed in home. So these are array declarations here. If you want to know more about them, just click on it, hit F1, and there's a fair bit of stuff in the help on dimensions about making arrays. Right. So the dim statement here is telling PB we've got to create an array, so it expects the name of the array to follow that, and then we have brackets that represent brackets around the number of, or the size of this array, we should say. This is a one-dimensional array. We can create two-dimensional arrays, three-dimensional arrays, four-dimensional arrays. But generally, you only ever use one-dimensional, maybe two-dimensional. Anyway, so here we're creating an array where each index within the array, each cell within the array, is used to store the exposition of the various characters on screen. We're using a Y array for the same thing. It's said it's storing the Y coordinates of the different characters. We have a speed an array for sizes, an array for here, for speeds I should say, for colours, those kind of things. To initialize them all, because initially all those arrays will be empty, they'll just be full of 0. You can prove that by using array. No, we won't touch on that. When the array is created, oh, excuse me, my voice is getting pretty hoarse. It is empty. All of the cells, all the numeric cells, will be set to 0 all the way through. So here we're running through, and from index 1 through to our number of characters variable, giving them a random set of properties. So a render loop is obviously rendering the characters and moving the characters and then wrapping the characters to keep them on screen. We could condense this a little bit more. We could actually take this X speed here and move it into an expression here, which might be freaking people out. So what we do, and we need to change that to Y speed. Just comment those out there for the sake of. So what's happening inside the loop is where when we start the loop variable equals 1, we come down here, we read from the size array at index 1, or cell 1, whatever you like to call it, which we're using our radius variable, which we're going to use later on, just for the sake of having it's a little bit shorter. Maybe it's more meaningful to say radius rather than in this context, because we are dealing with circles. after we go to the radius, we're drawing our character at its X position, this Y position, its current radius, and its current colour. We've condensed the movement code and the wrapping code into one line per axis. It's been a long night. Alright, so we've got this x-axis here. We're adding its speed, and then we're wrapping this result and storing it back into itself. That will keep it on screen. Let's run it to prove that's true. Pretty cool. And certainly not beyond you or anyone to get started. And a cool thing to do now would be to make some sort of interaction with those characters, but I'll leave it up to you, since this tutorial is getting way too long and it's getting really late. Okay, so I will leave this there. I will keep the code, obviously, and I'll post it up the tutorials. I know this has been kind of abstract. I'm really sort of trying to teach in terms of your objective. You know, if your objective is to make a game, then we kind of need to get to this sort of stuff here up and running. If you're still struggling with arrays, I mean, please go to the help files, go up to the about section here, and there are things called array basics. You know, there's a fair bit of information here. Check the examples out. There's an example there. It's kind of useful, actually. I think in the tutorial, like, we take this kind of central idea and sort of step through. So maybe you might find this a bit easier using combination with this video tutorial, but who knows, really. You know, but I will leave it here now. I really am struggling for things to say. So thanks for watching, and if you have any troubles, jump on the forums. You know, don't be shy, and ask a question. Show us what you're doing. You know, try and get your project up and running. It's a lot of fun for us to watch people start and get something up and running, and I know it's kind of frustrating when you're learning this stuff. This is pretty universal stuff, by the way. Arrays are found in pretty much every language. They have different rules a bit, but the concept is basically the same. Just think of a filing cabinet. You know, each array is like a filing cabinet. You can, in this case, we're storing instead of files, we're storing numbers, and we can reference the files rather than using a alphabetical reference or something like that. We're using just a numeric reference, an index. Alright, thanks for watching, and I will catch you next time. Bye.